In this fundamentals video, we're going to be talking everything quadratic formula related. So let's hop right into it. Here you go. Here's the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Probably a good thing for you to have memorized for school, in Algebra 2 or Algebra 1 maybe, and also for the SAT. So make sure you have that memorized, and this will solve any quadratic equation as the title of this video suggests. So what is a quadratic? It's any equation that has maybe an x squared, maybe an x, and maybe a constant. But most importantly, quadratics always have some sort of x squared term. And what this does is it basically bypasses factoring in case A, factoring doesn't work. Not everything's factorable. Or if factoring is difficult, maybe you can just switch to the quadratic formula instead of trying to factor a difficult question. So let's start with this problem, x squared minus 3x minus 10 equals 0. And we'll just plug it into the quadratic formula. And I'll just rewrite it here. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And the way we use this quadratic formula is first by stating what a equals, what b equals, and what c equals. Now, a is always the coefficient on the x squared term. And if there is none, then you put 1 for a, right? Because x squared times 1 would still give you x squared. The coefficient on the x term is your b. And make sure to keep the sign, -3. And the constant at the end is your c term. Now, it's very important, and I already did this for this problem, but it's important everything is on one side of the equation so you can have equals 0. Okay, and now all we do is we plug these numbers a, b, and c into the quadratic formula. So we want the opposite of b. Now, b is -3, so opposite of b is +3 plus or minus the square root of b squared. So -3 squared is 9. And then minus 4 times a, which is 1, times c, which is -10. And that's all over 2a. So 2 times 1, all over 2a. Okay, so now we just need to simplify this guy. And I will simplify what's inside of the radical first. So 3 plus or minus the square root. Now 9 just stays put. -4 times 1 times -10. That's going to give me +40. All over 2. And let me just get some stuff out of the way here. So now we have the square root of 49 in here, which is just 7. 3 plus or minus 7 over 2. Those are your two answers. Now, we shouldn't really leave it like that just because we can simplify. You can have 3 plus 7 over 2, and you can have 3 minus 7 over 2. And this gives us 10 over 2, which is 5. And this gives us -4 over 2, which is -2. And just by using the quadratic formula, we have solved this quadratic equation. We know that x equals either 5 or x equals -2. Could you have factored? Of course you could have. You could have said x minus 5, x plus 2 equals 0, and then x equals 5, and x equals -2. But either way, you'll get your answer. But sometimes they might ask you to do one way or another, and sometimes you have to use the quadratic formula. The quadratic formula is always something you can rely on. It's always something you can fall back on. So it's always useful. Sometimes factoring just happens to be easier. Now, when we're using the quadratic formula, which I'll write again, opposite of b plus or minus the square root of b squared minus 4ac all over 2a. There's like a little jingle you can memorize the quadratic formula with, but I'm not going to do that here. Now, before we plug stuff into the quadratic formula, I always like to see if I can divide everything by a certain number. That way, my a, my b, and my c are all a little bit reduced instead of plugging in 2 for a, 14 for b, and -60 for c. If I divide everything by 2 here, I get x squared plus 7x minus 30 equals 0. Instead of dealing with those bigger numbers, I'm dealing with the smaller ones now. And now I know that my A, once again, is 1, which is the easiest A to work with. B is going to be 7, and C is going to be negative 30. Cool. And I will plug that into the quadratic formula. And just so you know, this doesn't affect your answer at all. If you reduce A, B, and C, you still get the same answers you would have gotten for the original equation, just in a little bit less time because you're dealing with smaller numbers. So the opposite of B, negative 7, plus or minus the square root of B squared. Well, 7 squared is 49, minus 4 times A, which is 1, times C, which is negative 30, all over 2A, which is just 2. Reduce a little bit, and by reduce I mean combine like terms. So 49, and then negative 4 times 1 times negative 30 is 120. So 49 plus 120, and see if I can squeeze this in here. I think I can. Yep. Okay. And now it's just some simplifying. Leave myself some space up here to simplify. Negative 7 plus or minus the square root of 169 over 2, which is just 7 plus or minus 13. That's a perfect square. Negative 7 plus or minus 13 over 2. And then you break it up into your two answers. So negative 7 plus 13 over 2 and negative 7 minus 13 over 2. So negative 7 plus 13 over 2 is going to give me 6 over 2, which is 3. And then negative 7 minus 13 over 2 gives me negative 20 over 2, which is negative 10. So my answers are negative 10 and 3. So x equals negative 10 and x equals 3 in no specific order whatsoever. All right. One last problem. So, like I said earlier in the video, make sure you get everything to one side of the equal sign. And I like to always keep my a term positive, so I'm going to just subtract 5 to the other side. So 6x squared plus 13x minus 5 equals 0. Right? I just subtracted 5 from both sides. And I don't have a GCF, unfortunately, so I can't divide everything by a certain number. So I'm hopping right into A equals, B equals, and C equals. So A is going to be 6 here, guys. B is going to be 13, and C is going to be negative 5. All right. Opposite of B, plus or minus the square root of B squared minus 4AC, all over 2A. And now I just plug right in. Negative 13 plus or minus the square root. 13 squared is 169, like we said last problem, minus 4 times 6 times negative 5, all over 2 times 6, which is 12. Okay, let's clean up this stuff inside of the square root. So I would do the negative 4 times the negative 5 first to get positive 20, and 20 times 6 is 120. So inside of the square root, I have 169 plus 120, which is 289. Okay. And the square root of 289 is going to be 17. So negative 13 plus or minus 17 over 12. Okay, and that can be simplified. So break it into the two problems, negative 13 plus 17 over 12 and negative 13 minus 17 over 12. Okay, negative 13 plus 17 is 4, and 4 over 12 can be simplified to 1 over 3. So there's our first answer. And then negative 13 minus 17 is negative 30. Negative 30 over 12. We can divide both of those by 6. So negative 5 over 2. Now that one, it could have been factored. It just would have been a harder problem. Some of them you'll get that can't be factored. And some of them you'll get imaginary numbers, which we're not covering in this video. But if you ever get inside of the square root a negative number, that means it's definitely not factorable and you had to have used the quadratic formula or completing the square. That's another video to come. But I hope this video was useful. I hope you can put the quadratic formula to use. Make sure to follow me on TikTok if you want some short Brad Does Math videos. Just Brad Does Math on TikTok. And I will see you in the next video.
Brad Does Math.